Hey guys, welcome to the video. In this video, we will talk about the fundamentals of object-oriented programming. So let's start with object. Object is anything of interest that we are building. So it could be anything, a person, an animal, a bank account, a book, a library. It is anything that you want to store and process data about. And another name for an object is entity. Object-oriented programming helps us to think in terms of real-world objects. We can model everything as an object. An object has two things, properties and behavior. So if we try to model shop as an object, then the characteristics like name, address, and items, they will become properties of shop object. And the behaviors like calculating discount and getting the final price for an item, they will become the behaviors of the shop object. Now comes the most important part of the object-oriented programming, the four pillars of OOPS. This topic is not only important from understanding the fundamentals, but it is very, very important with respect to the interviews. So I have not given a single interview in my life where I have not been asked questions from these topics. So let's understand them one by one. And we will cover inheritance and polymorphism in more detail in the coming sections of this video. So the first pillar of OOPS is abstraction, which refers to the process of exposing only the relevant and essential data to the users without showing the unnecessary information. When we design our classes, so we decide that which data we want to expose to the outside world and which data we want to keep private. So that process is referred to as abstraction. So the next and most important pillar of the OOPS is inheritance, which is about maintaining a parent-child relationship between the objects. So this principle promotes the reusability of the code, and the child classes obtains properties and behaviors that are defined in the parent class. Next comes the polymorphism, which allows us to use the entity or the object in multiple forms. So we will discuss polymorphism and inheritance in detail in the next sections of this video. Now comes the last pillar of OOPS, that is encapsulation. Encapsulation prevents the data from unwanted access by binding the code and data in a single unit called object. So from the first impression, abstraction and encapsulation, they both sound similar, but they are not. Abstraction is showing relevant data and hiding the unnecessary information. So it happens when we are at the design phase, when we decide which data to make available to the outside world and which data to keep private. While encapsulation happens while we are creating the class blueprint, where we might create some helper methods which we don't want to expose, and we bundle everything together in an object. So this process of bundling everything is called encapsulation. So this is the basic difference between these two. Abstraction is happening at the design phase and encapsulation happens while we are actually in the coding phase. So now let's see inheritance in detail. So inheritance is all about maintaining a relationship between parent and child classes. So the class whose members are inherited is called the base class or the parent class, and the class that inherits members of the base class or the parent class is called the derived class or the child class. So one thing to note is that C# supports single inheritance. Let's understand it with the help of an example. So here we have defined one parent class named as base pizza, which has one field as price and its value is equal to 100. So now we have three child classes that are inheriting from base pizza, and they have a method to calculate the price and the property they are accessing from the parent class. Similarly, in Pappy Paneer Pizza and in Farmhouse Pizza, we have created these methods which are to calculate the price, and they don't have the price field available, but they are accessing it from the parent class. So these child classes or derived classes are inheriting this property price from the parent class. So this is the basic example of inheritance, where the field is getting inherited from the parent class. So during inheritance, not all the members of the base class are inherited by the derived classes. The following members are not inherited. First are the static constructors, which are used to initialize the static data of a class. Next comes the instance constructors, which we call to create the new instance of a class. So each class must define its own constructors. And last, the finalizers, which are called by the runtime garbage collector to destroy the instance of a class. So these things are not inherited in the derived classes. Except the above three, all the other members of the base class are inherited by the derived classes. But whether they are visible or not depends on their accessibility. So a member's accessibility affects its visibility for the derived classes as follows. So if we talk about the private members, they are visible only in the derived classes that are nested in their base class. So we will see it with the help of example. Otherwise, they are not visible in the derived classes. And for the protected members, they are visible only in the derived classes. And public members are visible as if they are defined in the derived class. So let's understand it with the help of an example. Let's see this example. This is not a very ideal example, but this is just for the understanding purpose. So we have a base class named payment, and it has three private, protected and public fields: amount, amount 2 and amount 3. So we have this nested payment class, which is a nested class within this payment class, and it is inheriting from the payment class itself. So if we see, we have created three methods: method 1, method 2 and method 3, and they are trying to access the private field. Method 2 is trying to access this protected field, and method 3 is trying to access the public field. So for the nested class that is defined within the this parent class, so for it, all the three members, public, protected and private, all these three members are accessible. But if we talk about this credit card payment class, which is not a nested class, so it is also inheriting from the payment class. But if we have the similar three methods which are trying to access the public, private and protected fields. But if we see, this amount is not accessible, and we are getting the error as the payment.amount is inaccessible due to its protection level. So the private fields or private members of the parent class are not accessible in the child classes or the derived classes. So the private members of the base class are not accessible in the derived class. So the derived classes or the child classes can override inherited members by providing an alternate implementation. So for that, the member in the base class must be marked with the virtual keyword. And in some cases, a derived class must override the base class implementation. And base class members marked with the abstract keyword require the derived classes to override them. So let's see it with the help of an example. So let's understand this concept with the help of code. So here I have created a class named Special Thali, where I have declared this method named breads, which by default has naan as an option. So I have this class my thali, which is inheriting from Special Thali. So by default, we have breads method in my thali, right? But because this method is virtual, so I have the option to override it, and I can have my own implementation. And here, what I did is I want paranthas rather than naan, right? So I have created my own implementation in my thali. So this is an example where we have created a virtual method, and in the child class has the option to override the virtual method. Similarly, we have created this example to understand the how abstract works. So this is the parent class. So it has created three methods named choose. So we have an abstract class named subway template, right? So it has three methods: choose bread, choose veggies, and choose sauce. All these three methods are abstract. So any class which will be inheriting from subway template, they have to provide their own implementation of these three methods. So what we did is we created a class named Aloo Tikki Sub, which is inheriting from subway template. So we have provided it's our own implementation of choose bread, choose sauce, and choose veggies. So we can provide anything, right? So let's say we can have plain bread in here, right? And similarly, we can have whatever sauces we want, and same goes for the veggies. So this was the basic difference, wherein if you define a method as abstract, so you have to declare your class as well as abstract, and you have to provide its own implementation in the derived class. wherein if you have a declared a class a method as virtual, so you have the option to override it. So let's now discuss polymorphism. So it is the ability of an object to act different in different conditions, and it is a Greek word which means many shaped. And in coding world, it has two aspects. So first is at the runtime, objects of the derived classes may be treated as the objects of the base class in places like collections and parameters, method parameters. So when this polymorphism occurs, the object declared is no longer identical to its runtime type. So we will see it in detail, right? And let's first discuss the second point, which says that base classes may define and implement virtual methods, and derived classes can override them, which means they can provide their own definition and implementation. And at the runtime, when client code calls the method, the CLR looks up at the runtime type of the object and invokes the override of the virtual method. So in your source code, you can call a method on the base class and cause the derived classes version of the method to be executed. I know it sounds a little complicated, but let's understand it with the help of code. So I have created one base class named iPhone 13, and it has one virtual method getPrice, which returns this value. And we have two derived classes which are inheriting from iPhone 13. One is iPhone 13 Pro and the other is iPhone 13 Pro Max. So they are overriding the parent class getPrice method. So here in the iPhone 13 Pro Max Pro example, in this method, it is returning us this value, and in iPhone 13 Pro Max, it is returning us this value. So let's talk about the first point, which we just saw in the previous example, which says that at the runtime, the objects of the derived class may be treated as the objects of the base class, right? So what does it mean? It means that, okay, so I have written this unit test to understand it better. So what I did is I have this list created where what I'm doing is I'm creating the instances of iPhone 13, iPhone 13 Pro and Pro Max, and storing it in this type iPhone 13, which is the parents or the base class type. So this was the first aspect of polymorphism, that we can store the derived class in the parent class variable, and it will be decided at the runtime which version of the base class or derived class method will be called. So when we call the getPrice method on all these three instances, so they return their own implementation. So the first is iPhone 13, so it returned us the value of 50,000. And when we called getPrice on iPhone 13 Pro, it returned us 70,000, which was getPrice implementation in the iPhone 13 Pro. Similarly, in the third instance, we got the value as 1 lakh, right? So I hope by this example it is clear. So that's it for today. See you in the next video. Thank you very much.